Standard form of quadratic equations. A quadratic equation is a polynomial equation whose highest degree is 2. The standard form of a quadratic equation is written as ax squared plus bx plus c is equal to 0. Where a, b, and c are real coefficients, a is not equal to 0 and x is an unknown variable. Saying that a, b, and c are real coefficients means that the variables a, b, and c can be fractions, decimals, irrational numbers, whole numbers, negative numbers, and so forth. It's all the numbers within the real number system. Another stipulation is that the coefficient a cannot equal 0, and x represents an unknown variable. Continuing on, the easiest way to work with quadratic equations is in standard form. So many times there will be a need to rearrange the equations. I also want to talk about why quadratic equations are named the way they are. Often the word quad is associated with the number 4. Quadrupeds are animals with 4 feet, or a quadrangle is a shape with 4 angles. So often the word quad is associated with 4, but here the highest degree is 2. Why is that? Well, recall that when a variable is raised to a power of 2, it is also known as squaring. This x squared term is associated with the area of a square, side length multiplied by itself. The word quadratic comes from the Latin word quadratus, which means square. So quadratic equations have the highest degree of 2. Standard form, example number 1. The following quadratic equation will be written in standard form. And standard form is ax squared plus bx plus c is equal to 0. Our example looks like this. 5x squared plus 3x is equal to 1. So we replace the variable a with 5, the variable b with 3, and you'll notice that this is equal to 1 instead of equal to 0. Standard form, the quadratic equation has to equal 0. The process will be like this. To convert this equation to standard form, we are going to subtract 1 from both sides. So I start with 5x squared plus 3x is equal to 1. Subtract 1 from both sides, and the final result will be 5x squared plus 3x minus 1 is equal to 0. The standard form of 5x squared plus 3x equal to 1 is 5x squared plus 3x minus 1 equal to 0. And we now have written this equation in standard form. Standard form, example number 2. The following quadratic equation will be written in standard form. Remember that standard form is ax squared plus bx plus c is equal to 0. The equation in question is x squared equals 6x minus 7. There are two issues here. We want to have all of the variable terms, all of the terms on one side of the equation, and the final equation should be equal to 0. To convert this equation to standard form, we are going to add 6x and 7 to both sides. So I start with my original equation. X squared is equal to 6x minus 7. I add 6x and 7 to both sides. Of course, these cancel. So this cancels and that cancels. And then I'm left with the final result of x squared plus 6x plus 7 is equal to 0. Therefore, the standard form of x squared equal to 6x minus 7 is x squared plus 6x plus 7 is equal to 0. Standard form, example number 3. The following quadratic equation will be written in standard form. And remember, the standard form is ax squared plus bx plus c is equal to 0. Here's our starting equation. It's the binomial 2x plus 1 times the other binomial x minus 5 equal to negative 10. Our strategy to convert this equation to standard form, first multiply the values within the parentheses and then add 10 to both sides. So we're going to take these values within the parentheses here, multiplying each term by the other term, like first times first, outer times outer, inner times inner, last times last, is going to give us 2x squared minus 9x minus 5 is equal to negative 10. Next, we're going to add 10 to both sides. So I add 10 to both sides, and our final result is going to be 2x squared minus 9x plus 5 is equal to 0. So in conclusion, the standard form of 2x plus 1 times the binomial x minus 5 equal to negative 10 is going to be 2x squared minus 9x plus 5 equal to 0.